We are going to discuss the constellation problem today. Let us look at the problem statement right away. There are three characters, okay? So let us highlight this. There are three characters, a hashtag, a asterisk, and a period. It represents a constellation of stars and galaxies in space. Each galaxy is demarcated by hash characters. There can be one or many stars in a given galaxy. Stars can only be in the shape of vowels A, E, I, O, and U. A collection of asterisks in the shape of vowels is a star. A star is contained in a 3 cross 3 block, and stars cannot be overlapping. Okay. The dot denotes an empty space. Now, the input is going to be in the form of a 3 cross n matrix comprising of the three characters, and we need to return the galaxy and the stars within them. And it is asking us to look into the shape of A. Looking at the constraints, there are going to be a lot of columns, and yeah, we covered all of that. Let us look at the input. So this is going to be the number of columns or the length of the row. I have denoted this more clearly in this pattern. If you look at this input, this looks like a U or a U, and this is an empty space. So we will return U here. Then this is the end of the galaxy, so we will return a hashtag here. Now this looks like an O, so we will return O here. Then a hashtag, and next this is an I. We will return an I. This is the end of the galaxy. Now, the interesting part here is that there are two characters here. This is E, and then right away, this is A. And this is going to be a star. This is a slight mistake. So this is going to be an A. So we will return E and A. So that is all for this example, but there is an example 2. And the interesting part about this is that there is an empty space here. So if you see 3 dots, you don't have to return anything. And yeah, that's all about it. So while visualizing the patterns, what we can do is if we encounter stars, we are going to look into the window of 3 intervals. And if we encounter a hash, we will look at the interval of 1. And again, if we encounter stars, we will look at the interval of 3 columns and so on. And a edge case where there is no star but an empty space. So we will look into all of these cases with the help of if-else and a brute force approach. Okay, now let's talk about taking an input. Our approach here is going to be to create a two-dimensional list. So I'll call it a matrix. Now we have 3 rows. So for dash in range 3, we are going to take inputs. So the row is going to be an input. But as you know, the default for input is a string. So in order for us to append this row into the matrix, we're going to convert it into a list. So we will convert this into a list. We will append this in a matrix and then print it for element in matrix. We're going to print this. Let us enter the input now. I'm entering 3 stars and 3 dots. So yeah, it created a matrix for us. Okay, now that we have the matrix, we're going to check for the edge conditions first. We initialize a variable I for the columns. We create a while loop because we cannot create a for loop as we're going to use 2 different conditions. Uh, we will increment by 1 when we see a end of galaxy or an empty space, and we will increment by 3 if we see a character vowel. So let's check for the first condition. If the first element is a hash and it denotes the end of the galaxy, we're going to print it and we're going to continue, which means we're not going to check any other condition. And we'll move on to the next iteration of the while loop. Similarly, the next edge case is going to be an empty space. So this looks like something like this. Um, so yeah, it looks like this, dot, dot, dot. If the column is going to look like this, we are going to increment by 1 and not going to output anything. Now, once we're done with the edge cases, we can now move on to the character vowels. So let us check for the window. If I is going out of bounds while we check for the vowel, we are going to break the while loop and not going to output everything. This is the most brute force approach that I could come up with. So what I'm doing is I'm looking for the individual patterns. If something looks like this in the uh, three size window, we're going to print E. And if the second row looks like this, we're going to output I. And similarly, I'll do it for O, U, and A. This is a very brute force approach, and this is not a very Pythonic way of doing things. What we can do rather is create a tuple of patterns, and we can match those tuple patterns with our windows of size 3. Looking into the more Pythonic and efficient way of solving this problem, we're going to we already have the matrix, we're going to create a dictionary of tuples explaining each pattern concisely. Now, we're checking if the matrix is empty or not, and if it is, we're going to return an empty string. And now let us create a helper function. So a helper function, what it's going to do is it's first going to check if the index is in bounds. If it's not, it is going to return false. Now this helper function is going to use a nested loop for row and columns to match the current 3 size window with the pattern. If it does not match, it is going to return false, else true. Now this is the same while loop. We're going to check for the galaxy separator, an empty string, and we're going to create a flag called is matched, and its default value is going to be false. Now for each 3-sized window, we're going to check for the vowel and the pattern, and we are going to pass it into our helper function called check pattern. If it returns true, this if criteria will work, and we will append the pattern into the result. Result is a string, and we are going to increment it by 3, and we'll move on. If it is not matched, we're going to move it by 1 column, and that's all. We won't output anything. And at the end, we're going to return the result. So that's all about it. I hope you will try this by yourself, and you can find the code in the description.